This is the second example from the naming binary ionic compounds topic. And in this case, our cation is cesium, Cs. Cesium is a group 1A metal, or group 1A element, and the elements in group 1A are considered invariant metal compounds. They will form ions, as far as we are concerned, always with the same charge, and for elements in group 1A, that charge will be +1, as we see here. So 1A, 2A, and aluminum are considered our invariant metals. So in this case, we have cesium of charge of +1, and our first anion is chloride, Cl -1. So to determine our empirical formula, we use the crisscross method. We take the value of this charge, cross it over here, the value of this charge, and place it there. So this ends up being CS1, Cl1, which is, of course, CsCl. So that is our empirical formula, CsCl. The reason the crisscross method works is because this ionic compound, by definition, is a neutral compound. So the charge of the cation must be canceled by the charge of the anion. So the empirical formula tells us that these cesium metal ions and the chloride anions exist in a 1-to-1 ratio relative to each other. How would we name this compound? We would name the metal as written on the periodic table, cesium. And then we would name the nonmetal with the IDE suffix. Chlorine would be chloride. And that would be the same for everything here. Cesium, bromide, cesium, fluoride, and cesium iodide. The empirical formulas would also be determined following the same pattern. And all of these cations are the same, and the charges of all these ions are -1, which is why the empirical formulas look very similar.